the key idea here is to convert optical signal into electrochemical current. So we developed a technique that can measure optical signal that allows it to take an image of the sample surface, but also a video of the entire process if you are trying to monitor a certain kind of processes, for example. So the benefit is that get optical signals very quickly without interaction with your surface very much, or sample very much. So then you determine the electrochemical current image based on the optical signals. So that's sort of a general principle. So the key innovation of the paper is that an entirely different way to monitor electrochemical current. So this allows us to solve problems such as the speed, if you compare with the conventional scanning electrochemical microscope, but also solve the problem perturbation of a probe to the sample you're trying to measure here. We have no probe, so that also solves that problem. So one example just demonstrates the capability of this technology in terms of providing new and additional information comparing to the conventional approaches. So one of the things we did is actually look at TNT together with fingerprints. So we have a surface which has fingerprints, and then we have a small amount of TNT traces. So if you look at the optical microscope, we're using a total, just based on a single technique, that is optical detection or optical imaging, you won't be able to see the TNT because they are, number one, they are very small. Number two, they are actually, the contrast is buried in the background of fingerprints. So you won't be able to see the TNT traces. But if you use electrochemical detection alone, you won't be able to detect these TNT traces either because you have just so little amount of TNT trace on the surface. You measure the total current, so you have a huge background signal come from the area where you don't have TNT traces. So the TNT traces come from small regions, sort of overwhelmed by the huge background from all the different areas of the surfaces and also different activities on the surface. So what do we have here? We demonstrate using this new imaging technique, we can detect easily the TNT traces because we combine this, the strengths of optical microscopy, which gives a spatial resolution, together with the high sensitivity and the selectivity of electrochemical detection. It's a bit more general perspective. This new technique is just think about the applications electrochemical detection methods have. Just a huge amount of different applications, from catalyst development all the way to detection of heavy metal ions in drinking water. So in principle, anything that you can use conventional electrochemical method, we can apply this new imaging technique to get additional information because we do have spatial resolution and high throughput.